sharp enough. Oh, it's all right. Right, there's the thickness of the wall then. I've gone a bit off.
Where did you just cut open?
Okay, so that's now into the little flies. That's now into the right ventricle. This meat in the middle, that's the septum that divides the right from the left. You can see the thickness of the wall. You can see as well these strings. Those are the tendons that stop the atrioventricular valve blowing inside out. So what I've cut through there is one of the papillary valves. These are really tough. Yeah, that will take the weight of the heart, no problem at all. These tendons are really tough things. What we've got here then, I've nicked it a little bit, but that there, that thin sort of skin, film almost, yeah, that is the atrioventricular valve that stops the blood flowing backwards, and it's got those tendons attached to it.
How come it's that thin and it can withstand all that pressure?
Well, it can. Obviously, it can. So from the atrium then through into the ventricle there, through the atrioventricular valve. From the ventricle then, it's pushing the blood upwards and outwards through there. So what's that vessel that it's coming out of there? From the right hand side, it's the
Pulmonary vein.
No. Pulmonary artery. Right. Let's just
Well,
open
carry
that up if I can. And with a bit of luck, I haven't cut it off too short.
Do people eat all of that?
Sorry?
Do people eat all of that? The fat and everything?
Probably. Well, when you cook it, a lot of the fat would melt. So well, you can see the thickness of the artery wall there. It's quite thick and tough. Quite thick and tough. So that would be a bit chewy, which is why they've cut it off close. But these here, that there is semilunar valve. Again, practically invisibly thin, but that's big enough, thick enough, strong enough to hold back the blood flow from going back into the heart. So there will be a couple of those pockets. One there, just got my finger under, you can hardly see it. So those are the semilunar valves. So again, from the atrium, through the atrioventricular valve into the ventricle, thinnish wall, but that's enough to squeeze it out then through the pulmonary artery. This one here, can't hardly grab it, that's going to be the aorta. Again, you can see big thick wall on that, really tough. It's got to contain a lot of pressure. If you have a look from the other side, see, I've cut in quite a way and it hasn't even gone through yet. That's gone through. We've got a much thicker muscle there. The left ventricle, much thicker muscle, because it's got to generate a lot more pressure to push the blood that much further. So again, there are the tendons, the strings that prevent the, I'll get my finger under, prevent the valves, the atrioventricular valve from blowing inside out. Big tough tendons, really strong. So cutting down through here then, there is some of the material of the valve. There's the big bit there. Okay, I've just got my thumb under it. You see? If I open that in half now, that bit there, with the tendons attached to it, which just tug on it to hold it in place, prevent it blowing inside out. And then when the ventricle is contracting, it's going to squeeze the blood through and out of the aorta. Again, you've got the same sort of thing. If I try and push my finger back, well, sometimes you can slip through, but generally it's going to catch in those semilunar valves that are in there. The septum in the middle, we go straight the way through that. You might expect to see something different in terms of the conducting fibres, the Purkinje tissue, bundles of His. Really, you can't. I've never been able to notice anything particularly different. Okay, but there you can see that the wall of the left much thicker than the wall on the right. Okay, all good protein for, you know, a lot of people like it. You usually sort of stuff a heart with something to, like, well, stuffing, I suppose. Give it a bit more different flavour. But, yeah. So, why throw them away? Alternatively, compared to other meat, you know, this is really quite cheap meat because not many people are keen on eating it, I suppose.
How much was it?
3 of them, £2 something.
Really?
How would you cook
Where
it?
from, sir? Honestly, I'm not. Because I'll go get them, you know that.
But often enough, stuffed with stuffing, onion and things, and roasted, I suppose, so the fat comes off. I think you wouldn't necessarily want to casserole it. Previously, though, because we've had more time and we've had a lot of hearts, I guess a lot of this stuff, you know, because it is good solid meat from one point of view, and it's cheap, where do you think it ends up? It's not going to go into landfill. So, I mean, some of it may go into pet food, but a lot of it will be disguised in things where you can't necessarily recognise the meat. Like
Sausages.
Sausages, maybe. You don't tend to get too much lamb sausages, but you can do. McDonald's and stuff like that will certainly make use of these things, pies and whatever. Yeah. So, sorry. You can have a look, a closer look if you want. Yeah, it's just meat, like you would have in the kitchen.
Oh my god! This is great!
Where's the other piece from?
No, don't be silly with it. By all means, if you want to have a closer look, do.
What was this again?
Those are the tendons that prevent the valves from blowing inside out, the atrioventricular.
That's quite strong, isn't it, sir?
Really strong.
Yeah.
Like steel cables.
Is it made out of cotton? Oh no,
Collagen.
Hard? I thought it was soft.
Yeah?
What's
yeah.
this?
Why is it cold, man?
Obviously, corn ain't going to be warm,
What
is
do
it?
you
Not
think?
cooked,
It's
is it?
freshly roasted. Do you think I've just gone out the back and butchered a sheep? So of course it's cold, it's been in the fridge.